In the real world of DevOps, we don't ever want to be deploying infrastructure using the console, but that leaves us with a chicken and egg problem. We can't provision resources without authorization, and we aren't supposed to click resources in the console. So we have to get a user or a role first with some permissions by clicking in the console. Normally, with larger organizations, your company will use an identity provider like Okta or Ping Identity. That will be hooked up with your company's Active Directory implementation or your company's Google Workspaces account that has all of your users in it. From this point, you would be accessing your accounts like AWS or Azure using the company user in AD or Google and whatever IDP you use with single sign-on. And this process is done with the help of your identity provider as a single point of authentication where it will give you an auth token, and that can be exchanged for credentials with each of the other services you'll use, like AWS or your Azure account. So from that point, as you have a user, you can then use that role, you can then use a role from that point to do your work. And in my case, I don't have an identity provider, so I'll just be using a user in my own account. To get started with Terraform, there's a few housekeeping things we need to do first in AWS and also on our local laptop. We need some credentials on our local computer to give us access to run code in AWS, and we need to provision a way for our local computer to be able to authenticate with the AWS APIs, and importantly for Terraform to provision infrastructure for us. So first of all, we need to go into the IAM console and set up a user with some access keys. So let's do that right away. What we're going to do is we're going to jump in the console, we're going to click into the search bar, and we're going to type in IAM. The first result is IAM. We're going to click into this, and once we jump into that part of the console, we are going to look at users, and we're just going to go ahead and add a user. And I'm just going to call this user Terraform. And we're going to give it an access key, and we're not going to give it a password because we're not going to use any console access with this Terraform user. This is purely for the CLI. So next, permissions. So what we're going to do here is, if we've got a group, I've got another group here from another experiment that I was working on, but if we've got a group, we can add a user to a group. Your company might have something like this already set up. We can copy permissions from another user, or we can attach existing policies directly. Ordinarily, if your accounts are already set up, as they probably will be, you'll be doing this using code. However, because I don't have any of that stuff set up in this account so far, I'm going to attach a policy directly. That said, I would recommend that you always create a custom policy and steer clear of these managed policies for a good deal of the permissions that you hand out. You'll find that some of these AWS managed policies don't exactly fit your use case. So in that light, I'm just going to give this Terraform user access to EC2. I will say EC2 full access, just in the interest of making sure there's no errors in permissions. And I'm not going to bother with the VPC or anything else like that. This should hopefully do us right for the purpose of this particular demonstration. So just one thing quickly we can probably have a look at here in the policy. There are a lot of things in this full access policy that, generally speaking, not very many things are going to want to have all of this kind of permissions. So we've got all auto scaling, create a service linked role. That would be pretty undesirable if we could just give a role permission to set up other roles. So we don't want to do that. But it does have permission to do the main things we want to do. EC2 allow all. I mean, this is quite a lot of things. And yeah, like I say, this is probably undesirable for the most part. But this is just a demo, and this user will be deleted very shortly after this demo is complete. So we'll go next tags. I'm not going to worry about tags. I'm going to review. We've got a full access for EC2. access key with no password will create that user. So once this user is created, we're going to hit this download CSV file, and we're going to save it on our local machine with no need to look at this just now, and we'll just close that out. From this point, we're going to come back to here, and we are going to look at, not one, we're going to look at this one, the CLI. So I've already moved across to the projects TF demo folder. I set this TF demo folder up for this specific demonstration. I recommend that you also set up a projects folder on your local machine for anything you're working on in your own. And when it comes to your work stuff that you'll be doing with your own company, I really recommend you speak with your colleagues about how they have it set up, because there's probably a way that they're doing things that makes sense for you, the way your organization will do things, and you should copy them. But for this demo, I've just got a folder sitting in projects, and this is an empty folder. There's nothing inside of it. So to begin with, we're going to check a couple of things. So I recommend you check as well. Have a look and see if you've got AWS CLI installed. I don't have it installed here. And also have a look and see if you have Terraform installed on your machine, and I don't have it installed here either. So with a Mac, if you have Homebrew installed, which I recommend you also install if you don't have it installed, you can just do brew install AWS CLI and Terraform. And that should go ahead and install both of those applications for us, and then put them in the path for our shell to be able to get access to them. So that's really convenient. For Windows, I think there's an MSI installer you can use, but the AWS documentation will help you out with that. So this will just take a minute. And once that's done, yeah, we're ready to go again. So for now that we've got AWS CLI installed, we can just type in AWS and we should see the AWS prompt come out. That's good. And also with Terraform, we can see there's a prompt there as well. Perfect. So from this point, now that we've got our access keys and our AWS CLI installed, we're going to configure the AWS CLI in a way that lets us use those keys. So there's a couple of ways you can do this, and I'm going to show you both ways and the way that I recommend that you set up your credentials. So AWS Configure is the command that most people will use at this point. And you can just type this straight in and it will prompt you for your access key, secret access key, your region, and your default output. We're going to do this right now just for the sake of the demo, but I really, really recommend that you sort of follow along with what I do afterwards to see the way that you should really be doing this. So in my other window here, I'm just going to pull up the other user or the user's credentials, and I'll drag this up on screen for you guys to see. So we can see here we've got all of the things that we need for this. So in here, I'm going to grab this access key. I'm going to paste that access key right in there. And then I'm going to grab the secret access key here. And then I'm going to paste that one in there. The default region that I'm going to use now is AP Southeast 2, which is Asia Pacific, Southeast 2, which is Sydney. And then I'm also going to use the output of JSON. The options for this is text, table, and JSON. And so I prefer JSON as the output. And that's cool. So once we've got this done, we can test that this works by doing AWS STS, which is the session token service, get caller identity. And this should go to the API and return us our user. And you can see that our user, Terraform, has been returned. So this is our current user, and that's my account there. So we can see that this is correctly configured. The problem with using default credentials is that when you open up a new shell, these credentials are ready to use, and it won't take you any sort of brain power to just jump in and start typing in AWS commands or running Terraform stacks against that identity. But the problem is that once you've got more than one identity, does become a bit tricky to keep track of which one's which. If you've got one's a default, you might forget to change to the other one, and this can lead to some really, really big problems. And there have been plenty of instances where people have wiped out production accounts or production services by not paying attention to the correct profile they're using. And you can also run up a bunch of money by doing this as well, by setting up infrastructure on the wrong account. So I really recommend that you don't end up doing things this way, or follow along here and you can see how we can kind of remediate this. So where this configuration's saved, it's in a hidden folder in your home directory. So what we're gonna do is we're gonna use Vim, the text editor, and we're gonna use tilde for the home folder, /.aws, which is a hidden folder. The dot indicates that it's a hidden folder, AWS, and then in here will be two specific files we care about. One is the credentials file and one is the config file. So let's take a look at the credentials file first. And in the credentials file, you can see that's where it's saved our access key and secret access key. And it's under this default profile. And we don't really want this because of the reasons I just discussed. So to remediate this, what I'm going to do is I'm just going to put a few new lines in here. I'm going to insert some more square brackets, and I'm just going to put in Thomas as a new profile name. And then under the default one, I'm just going to leave that blank. So that's two separate profiles. So I'm just going to save that and exit, and we're going to go across to the config file. And in here you can see we've got our default profile again with the region and the output type. So I'm going to also, I'm actually going to leave that one as it is. And I'm going to, below this one, put in a couple more square brackets, put in a Thomas profile. And then below that, I'll put in this exact same text right down below there, because that's what I want. And then what I'll do is press escape, :W for write, Q for quit, and exit. So that should be good. Now, if I do AWS STS get caller identity again, this should fail. Yeah, unable to locate credentials, which is, this is the error message we want to see when we've not thought through which profile we're using. So when you jump into the shell and start doing AWS commands, this should come up by default as the thing that says, hey, you didn't choose a profile yet. I'm not going to let you make a mistake. And this is highly desirable. So, and then the way we're going to run this now to be able to select that profile is we're going to export it. So export, and then in capital letters, AWS _ profile equals, and then the name of your profile, whatever you've called it. And then we press enter. And then if we do that exact same command again, AWS STS get caller identity, this time around it should work because I've explicitly told it to use that profile. Once we're done using a profile, what we should also do is unset it. So unset AWS profile, and that will then deselect that profile for use. And if you try to run this command one more time, it will once again fail. This is desirable behavior. Okay, so I'm just going to reselect that, export AWS _ profile equals Thomas, and we're good to go. All right. Now, so now that we've got this done, and we've proven that the AWS CLI is working with the APIs, we're sweet as far as AWS is concerned. From this point, what we're going to do is we're going to go set up Terraform. So how are we going to do this? Let's jump across to VS Code. So I'm currently in the TF demo folder, and what I'm going to do, I'm just going to double click in the main screen here to create a new file, and I'm going to Command Shift S to save this, and I'm just going to call this Terraform.tf. A note about Terraform naming structures: it doesn't really matter what you call this. Terraform treats any file called .tf as one massive file. So if you have 10 different .tf files. Terraform doesn't see files or file names. It doesn't care about what you call them. It just picks up all the TF files, smashes them all together, and runs the entire thing in one go. So this is a convention that I've picked up from one of my previous employers, where we want to sort of outline some of the Terraform details in a Terraform TF file. And I also recommend that you do this too. And we're just going to save that just like that. And you'll see that this Terraform TF file saved over here with this nice icon. A couple of things to maybe think about is in this icon right here on the left-hand side, the extensions icon, you can open this up and you can search for some Terraform extensions. And there's one here that's quite popular, which is quite good, which is this HashiCorp Terraform. This version's 2.3.0. It's quite good, so I recommend you probably get a hold of this one. There's a handful of other extensions you might want to look at in here as well for other bits and pieces, but that should do it for now. So from this point, what we're going to do is I have some sample code saved right here that I'm just going to bring across and paste right in here. So this code is a Terraform block, and it has some required providers for the code that we're going to run. And the required provider is the AWS provider. And the version of this provider is one of the more recent versions, although not the most recent. And the source of that provider is HashiCorp/AWS. That's where Terraform is going to go out and find that provider from HashiCorp directly. Now, below that, we've got a provider block with AWS as the provider, which is a direct link to this provider right here. And I'm going to give it a profile called Thomas, because that's what I called my profile in my AWS CLI. And the region, I'm going to override everything there and explicitly stipulate that the region is going to be AP Southeast 2. Now, if we save this and go back to our shell, I'm just going to clear this to make this a bit easier to look at. And in fact, I might make this a bit bigger as well. So at this point, if I do an ls, we can see our Terraform TF. Now, if I do Terraform init and press enter, oh, did I miss Terraform here? Brew, install. Oh, I misspelled it. Terraform init. Yeah, okay, cool. So here we go. So it's initializing the backend, which is a local backend. What that means is not really worth worrying about at this point in time, but later on we'll be storing all of our backend configurations in S3. And what Terraform is doing is downloading that HashiCorp AWS provider, that version that we gave it. It's installing it and told us that it has installed it. It's created a lock file, which we'll be able to see over here on the side. And it's telling us that Terraform has been successfully installed and initialized. Great. Nice big green blocks of text. It's really nice. Okay. So once again, I'll clear that just to make a bit more space to look at this. And then, so once we've initialized Terraform, what a Terraform init does is it, like I said, it creates this lock file, and it also creates this hidden Terraform folder. Hidden meaning there's a dot there, and in the file system you won't be able to see this. But if we open up this Terraform folder, inside here we have a bunch of things, well, not a bunch of things. We've got a providers folder with the registry with HashiCorp AWS and the version of the provider we've downloaded. And if we had anything else that we kind of wanted to provision here and we had that outlined, those other things might also be provisioned here as well. So, and once we've got a state file from things that we've created, that state file will also live in this folder. So we'll come back to this at another point, but this basically here is all the Terraform you need to start using AWS. So if we come back to the shell here, and if I do Terraform plan, no change. So basically this is telling us that everything's basically sweet because we haven't got any resources yet, and that's fine. So what we're going to do next is we're going to create a main TF. So I'll just double click up here in the header bar, and I'll Command Shift S, and I'll call this main.tf, and I'm going to save that. So what we're going to do here is we're going to create an EC2 instance, and we're going to create the most basic most basic possible EC2 instance you could possibly make. So what we're going to do, we're going to change over, we're going to do a search for Terraform EC2 and just search for that. Now that will bring up the manual page from Terraform. We're just going to scroll down and find this one here. No, is it? Yeah, AWS instance. That's what we want. So in here we can find a resource for an AWS instance, and this code right here is everything we need to create an instance. So I believe it will be everything we need to create an instance. So what we're going to do, we're going to go back to our code and we're just going to paste that right in there. Maybe that we may need to set up the VPC stuff as well. Yeah, so having a think about this, I think we also need to outline the VPC that we want to deploy this instance into. So whilst this is enough to deploy an EC2 instance, we also need to tell it where to be deployed. But let's quickly go over what's on screen here. What we've got is a resource and we've got a data. And these are the two basic building blocks for when you're going to build out any of your own Terraform. What do these mean? Resource, you can basically think of as meaning go and make me one of these things right here. And a data object means go and get me one of these from my provider and return me back that data so that I can reference it. There is a couple more types, and one of those is a module where we get to package this up into some kind of abstraction that we can then reuse later on. But we'll be covering that soon enough. So let's quickly set up the other things we need. So to be able to set up everything we need for this instance, I'm going to go back here and we're going to go down and look for, actually I'm just going to search for AWS Vpc Terraform. Cool. So data sources, perfect. So we're looking at a data source for AWS VPC here. So what I'm going to do is I'm just going to grab this sample code, copy it. Actually, we don't need the second part because that's going to be probably a data as well. So just going to copy that part, come back here, we'll paste this in. Actually, I'm just going to give this a default. And then I'm going to jump back to my account and copy the account ID. And I'm just going to set this as the default value for this. That way I haven't got to mess around too much. So there's a variable object here, or a variable type called the VPC ID. I'm going to give it a default value so I haven't got to explicitly say what it is later. And then we're setting, in actuality, what we can do here is just probably just get rid of that whole lot there altogether. and just type in the actual ID right there, and that should be good enough. So the data object will go and get a VPC ID or ID, and what you'll notice as well is there's a type of thing, and there's a third part of the line here, which is a name. These names are totally arbitrary. They don't really matter what you call them. You can call them anything you want to. It's a way of saying when you're calling it. For example, in this line here, I want a data object of a type of AWS AMI. You might have 10 AMIs outlined in this file or in this stack, and you want to choose the Ubuntu one. And this one here is the one that's called Ubuntu. So that's how it's kind of lined out. So we've got a data object for an AWS AMI called Ubuntu with a bunch of things that outline the type of thing that it is. And I might want to have another kind of data object that goes and gets me stuff from the AWS provider that has Amazon Linux too. That's also an option. That's why it's set up in this way. So we've got a VPC ID there, and we'll come back to here. And we also want to get a subnet. Search for Terraform subnet data. And then we'll grab this information in here that we need. So we're going to go yeah, that's fine right there. In fact, it may not even be the case we need the VPC ID there. On for that for just a moment. Let's go jump across to the Vpc console. I've already redeployed a stack into my account with an entire VPC with all the things that I need. And we'll be covering this shortly in another video of how to actually use Terraform to create this. But I'm going to jump into here and I'm going to choose a public subnet. For example, this public B is fine, and I'm just going to grab that whole subnet ID and go back to here and just put in that like that. So any strings need to go into double quote marks, and I really think that ought to be enough. I'm just going to comment that out with a command backslash or front slash backslash, and that should be good. So what we've got to do now is tell this instance where we want to deploy it. So we'll go back to this AWS EC2. Actually, data sets for that, we wanted an actual instance. Yep. So in the documentation, we've got an argument reference. This is where all the bits and pieces that you'll find that you can use to outline the specific kind of instance that you want to create or resource of any kind you want to create. And availability zone is the exact one that we want to have. So let's go back to the code, and I'm just going to paste in right here. Availability zone equals, oops, that ID. And this is going to go in some quotes like that, and we'll save that. So really, this by itself, in this code here, will go out and make us an instance. The instance itself doesn't have all the things that we need to make it useful, but it's still an instance. So let's see if it works. So if we go back to our code, and if we do another Terraform init to make sure we pick up any changes that we might need. So it'll initialize, it'll grab the plugins, and that's already up to date. And then we'll do another Terraform plan. Okay, so the first error we've got is on one of the skills you're going to have to pick up very quickly is working out how to read these error messages. Error, invalid reference. Okay, where is it? It's on terraform.tf on line 11 in provider AWS. So Terraform TF line 11, Thomas, it needs to be in double quotes because it's a string. All right, let's try that again. Cool. So the really nice thing about Terraform, or one of the really nice things about Terraform, is it gives you a really, really nice outline of what it's going to do. Very explicitly, very unambiguously. And I really like the way they lay this out. They've done a really nice job about this. So it tells you the exact AMI it's going to use. Some of these things can't be known until after the resource has been created. So it's going to be known after apply. We know what subnet it's going to go into. We know it's a T3 micro. Now, did we outline that in this at all when we created this? T3 micro, we did. Cool. Okay. What else is here? Source destination check is true. I think that's a default. And everything else is seemingly not enough to reply. It's going to give us a block device, a volume to use. We've got a few bits and pieces here. This type of instance has an ephemeral block device, which is a type of volume. And we get a network interface without any configurations and a root volume without any configurations. And it's going to tell us we've got 1 to add, 0 to change, and 0 to destroy. So that's cool. So from that point, now that we've got all this worked out, we can just do Terraform, apply, and press enter. So this shouldn't take very long. What you'll notice is we've got our lock came in here. We've got a state file that's in here on the other side as well. So when you do an apply in Terraform, what it does is it effectively does a plan a second time. So you'll notice we've got our first plan is here, and then it showed us everything it wants to do. Then we ran apply, and it gives us a plan a second time around. So it's like, are you really sure you want to do this? And we can go down and see everything hasn't changed. And then it says, do you want to perform these actions? We're just going to do yes. Only yes will work, Y will not work. And that, okay, what's the problem here? Error launching source instance, VPC ID not specified. Okay, so we do need the VPC ID. Okay, so we need a VPC ID. So if we go back to the AWS instance, I'm just going to search for this VPC ID. There we go. Okay, cool. Which goes in the subnet. I'll just copy that. Some dummy code. So I'm going to on-comment this, and this is, I'm going to rename this to be my underscore VPC. So it matches up with this example here. So they match, they're the same. There's an exact thing there. And we're going to say VPC ID of this subnet is an AWS VPC dot my VPC dot ID, and the ID is this value right here, which resolves to that one there. And actually, that's my account ID, so that's totally wrong. We need to go back to this one. And this has got to be a string as well, so we put in the double quotes. Hopefully that will fix that. Let's have a look. Okay, another error here. We need, this has got to be a data. So it's the type of this actually has to have data. in the front of it to say that there's a data object. Okay. So I'm going to leave all of these errors into the video so that you can kind of get a sense of what it's like to do this and the kinds of things that I'm looking at. Another error. Error launching source VPC not specified. No default VPC for this user. Okay, so I think I've figured out what I've done wrong here, and I think that this is not supposed to be availability zone. This is actually supposed to be subnet ID. That's the error that I've made here. So let's try that again. Type in yes. Okay, so far it looks like it's doing what I expect it to do. That will take a few seconds. Oh, there we go. It's already completed. So, and that's done. So, and it gives us a nice output. Apply complete, resources, 1 added, 0 changed, 0 destroyed. Perfect. We'll have a quick look at our Terraform folder now that everything's been done. So if we open up this Terraform folder, actually that's still going to be static as it is, yeah. And we've got this provider file, which is not displayed here. And we've got our lock file and we've got our state file. So this state file is the important information about what we've deployed against the account. Terraform tracks at all times. So it's really important that you don't really interfere with this until you've got a good handle about what you're really doing with Terraform. There's quite a bit of data in here considering how little code we wrote, because there are a lot of things got created with some specific IDs that need to be sort of tracked. And this will also help us out with our diffs when we do another plan. If we change something, this will be referenced against the what's in the account to see what's been changed. And we've got a state backup as well. And all we've created so far is our Terraform TF and our main TF, and everything else has been sort of auto-generated for us, which is quite cool. So let's jump back across to the AWS console and let's go to the EC2 part of the console. And in here, we should see our instance. And we do. Now, the reason why it's called Hello World is because in the code, you'll note that the name tag is Hello World. So that's how we name resources, with the tag called name and then give it a value for the thing we want to call it. And that's quite handy. So we've got this EC2 running. It's a T3 micro. It's still initializing, but that's quite normal. And let's have a quick look at why this instance is basically not very usable. We don't have an IAM role attached to this instance, meaning that we can't really use some nice things like the systems manager. We can't do any external patching. We can't create a shell in the console. We can't run commands against the machine, and we can't look at what the internal stuff is happening on that machine from the console. That may or may not be a problem depending on your security profile at your organization, but that's definitely something worth thinking about. The second thing that we can see over here is there's no elastic IP address on this instance. What that means is if you stop this instance for any reason, not terminate, but stop, and then you restart this instance, it will get a brand new public IP address. So this IP address will be returned to the AWS pool of IP addresses, and a new one will be provisioned. That will probably be a problem for you as you're going forward. So you may want to provision an elastic IP address that will always come up on this instance. What else? So there are some bits and pieces like we've not stipulated a key pair for this machine, this one here. There's no SSH key pair. So not only can we not use the systems manager to connect with it, we also can't SSH into this machine to be able to do anything with it because we didn't save any keys for it. So this machine at the moment is just going to be able to cost us money, and that's about it. So the next part of the demo that I want to kind of run with you guys is I want to change this name to something else so we can see what a diff looks like in Terraform. So what we're going to do, we're going to jump back to the code and we're going to delete this hello world and we're going to call this machine my_machine, and I'll just save that. And we're going to jump back across to the shell, and we're just going to run another apply again against this. And what will happen is it'll spin up its engines, it'll go out, it'll check the state, whatever's actually live in the console, compare it against what's on the state file that it's got, and it'll show us a few things. So in the last plan, you'll notice everything is green tick, green pluses here. So these green pluses mean it's going to create, and you can see that it's going to create all these things here. So create is a green plus. When you're going to modify things to make them different, they get these nice yellow tilde symbols next to them. And you can see here, update in place is a yellow tilde. And we're going to modify the tags, and the name tag is going to go from hello world to my machine. And there's also a tags all here, which does the exact same thing. And then a bunch of the other attributes are hidden, so there's no distractions there. And at the bottom of the plan, it says 0 to add, 1 to change, 0 to destroy. I'm just going to press yes on that. That should be done in no time at all. Perfect. And if we go back to the console and we hit refresh, we should see the name of this machine is updated to my machine. Very cool. Okay. So now that all that's done and we've kind of gone over what we can do with just grabbing a few Google searches and pasting them right into the code here, we're going to destroy this machine. Quick note on what will happen if you change significant things here. If I was to remove this Ec2 instance or some other part of this and then replace it with something else, it would, like, for example, if I was to change this from web to, I don't know, bananas, and that's all set now, right? So that's effectively changed that entire resource altogether, because in the state file this was called web and now it's called bananas. So as far as Terraform cares, this is a whole different machine. This isn't modifying the machine, this is a new machine, and we've deleted the web machine and we've created a bananas machine. So this is the Terraform name of this instance, and the old one's gone and the new one's here, even though everything else is the same. So I expect that this is not going to modify anything. This is going to replace something because it's a new resource. So let's go back in here and reapply this. And we should see that this is going to destroy one instance and create another one. No changes. That's odd. Oh, the reason why there's no changes is because I didn't save it. You can see that there's a white dot right there. That's unsaved. So we'll go back, rerun this. Cool. So now we can see we've got 1 to add and 1 to destroy. So we're going to add in our new bananas machine and we're going to destroy our web machine. And we have a really nice diff of what's going to be done. All the things that are going to be made, all the things that are going to be deleted. Very nice. I'm not going to do this, so I'm just going to hit no. And what I'm going to do now is I'm actually going to shift this back to how it was before. Save it. And this time I'm going to do a Terraform destroy. Terraform destroy will do the exact reverse of an apply. It will go out and it will get rid of everything. And what you'll see now is we've got all these nice big red minus things that say we're going to destroy the things, and all this stuff is going to get destroyed And that's what we want. So I'm just going to type in yes. And all of this infrastructure we created here will be destroyed. And this shouldn't take very long at all. The next thing I kind of want to make really clear here is that when it comes to making things like this, the sky is really the limit. You can go out to and search for all the resources you like and sort of push them into these files and create quite complex things. And that's kind of the nature of using Terraform. Up next, though, we'll be covering how to use modules, and that will hopefully make things a bit more clearer as to why people really like being able to use Terraform. Perfect. So that means that our resources have now been destroyed. We go back to the console and hit refresh. We'll see that our machine's been terminated, and that's what we're looking for. That's perfect. So that about wraps up that part of the demonstration. And next up, we'll probably move on to the modules. Now that we've been over some of the fundamentals of what Terraform can do as far as creating specific resources, I now want to go over with you guys a bit more information about how we use the modules. Now, one really good module that I've come across is this Aws Vpc module. And this is in the Terraform registry. There are a boatload of really, really good modules available in the registry. And I recommend you spend some time and go look at some of them because some of them are really well done. Quite a few of them, shout out to this guy, Anton Babenko, who I'm pretty sure has written more Terraform than anybody else on planet Earth. He has a lot of repos he's involved with and is clearly quite knowledgeable in it. So what we've got here is the provisioning instructions on the right-hand side. What you need to do to be able to use this module is paste in this block of text. And this is the minimum you've got to do, and then you've got to insert the 21 required variables here. When it comes to modules, there are optionals and there are required variables. The module will tell you exactly what you've got to do, and quite a lot of them explain with some examples, which we'll touch on in a minute. But pretty often the good ones have something you can just basically copy this, put this into your own folder, and provided everything else is already set up, you can run it and this will set up the exact right things that you need. Tags, NAT gateways, VPN gateway. There's a whole bunch of really nice things in this module. It's very well made. So we scroll down a little bit, we can see some information about elastic IPs for the NAT gateway. So they've provided some code, some sample code for creating 3 by count of these elastic IPs in a VPC. There's a handful of other things if you scroll down and look through all of these things. So one of the things I mentioned in our VPC talk earlier is that NAT gateways, if you just provision one, it won't be highly available. But if you provision 3 of them, you do need to provision more route tables for the private zone to allow all that routing to work the way you want it to. And it's also going to be more expensive for you to run that. And there's a bunch of built-in functionality here for how you can set up your NAT gateways to how you want to have them. And this might be worth having a read through as well at some point. Lots and lots of examples and details about how this module works. And we can also just jump right into the example code, and it does give you quite a few examples that you can choose from. What I want to do, rather than looking at the example code, though, is have a look at the source code. So we're going to jump across to the source code, and we can see that there's quite a lot of stuff going on here. A couple of the things that you might find are in nearly every single module we're going to come across is going to be something like a README, which has this data down the bottom here. You're going to have some outputs. So a lot of good modules have outputs. When you finish running your module, it will actually kick out at the end of it in the shell a bunch of details about the things that you've created, some of the details like the IP addresses and things of that nature. There's going to be some variables. The variables are the overrides that you want to be able to give to your module to say that these are the things that I want my module to be different from the stock standard options that it gives you. And we've got a main TF. So in the same way that our instance had a main TF, modules are going to have a main TF as well. Could be the case sometimes that someone may have gone to the effort to break out the main into several different parts. So for an Ec2 instance, you might want to also have an auto scaling group, and you might want to put that into a module. So you might have all of the auto scaling group stuff in an auto scaling group.tf and all the EC2 stuff in an EC2.tf rather than just having one main TF. It's a convention. It's up to you if you want to build it that way. Modules can also build on modules. So you can have a module that encapsulates other modules to make bigger, nicer things. So we're going to go into the main file. In this main file, we're going to see quite a few things that are going to look pretty familiar right off the bat. So we've got a resource of an AWS VPC. This is called this. That's another convention. And it's just another arbitrary name. And so let's not worry about count for now. But so we've got all the things that are required by a VPC to create it, all the different bits and pieces you can kind of bolt onto it. And they're all broken out by these var.cider, var.tenancy, var.enable, all these different things. And these vars are the things we're going to find in the variables folder. So there'll be a variable in the variables folder called cider. And that's something we're going to want to be able to override in our implementation of this particular module. So we can say our cider block is going to be 10.10.0.0/16. That's the size of our cider block. And that will be overridden by our implementation when we call this module up. So we don't download modules, we call them by their reference. And then there's a bunch of other things in here that kind of make this work the way we expect it to. So there is a lot of things like dynamic, and these can be quite difficult to understand at this level. So we're just going to skip over a lot of this, and maybe we can cover this in a bit more detail at another time. But there's a bunch of things in here. DHCP option sets will be set up. Internet gateways will be provisioned and attached where required. Egress only internet gateways are here. Everything you need, it's all in here. So if we go back to the parent folder and look in variables.tf, we can see all these variables. Do we want to create the VPC? What's the name of the VPC going to be called? What's the cider block? And we have some of these things have defaults and some of them do not have defaults. The things that don't have defaults, more often than not, it's too difficult to give a default. So we just make it as a mandatory thing that you have to stipulate in your variables. If it has a default already here, it will just create with whatever defaults that are already in the default argument. Please do not download a module and then override all the defaults and try and deploy the module directly. This is something that's very, very hard to remediate. So you can see all the variables that are in here. This is all very nice. And the outputs TF, very similar to the variables. It just has an output argument. We give it a name, a description, then a value. And the value is that we're going to grab the VPC ID, the first element. I'm not that familiar with this, so but what it will do is it'll basically grab all the name, the ID, the ARN, the cider block, security group IDs, and it'll kick these out at the end of the apply and show you what they are, so you can reference them directly. It's quite a nice feature. So and the rest of it is like a license. There's some make stuff here as well, which is quite interesting, but again, that's another topic. And in the examples, we can go in and have a look at some of the stuff. For example, a complete VPC, and we can open up the main TF, and this is what you would use on your own computer to create this module. And I'm going to show you what I've used to create mine, and you could also go to my GitHub and see that the implementation that I've used here. There's a lot of extra things in here. I would be very careful about creating too many extra things for your VPC because some of the endpoints do cost money to run. So if you provision endpoints or if you provision NAT gateways, they will cost money on your account. Some of them more expensive than others. And if you don't strictly need them, I would recommend not giving away money to AWS for no reason. So that's a really nice example of how to set up a bunch of things. And you've got all of these extra overrides, like you can set up a whole elastic hash subnet, a Redshift subnet, public and private. It's highly flexible, and I recommend having a good look at this one. So all of that covered, I'm going to jump across to my code and let's have a look at the VPC setup that I've got for mine and how I've implemented it with my my localization for this. So we still have this terraform.tf file, which tells Terraform what we're doing. We're using an AWS provider, and you can use any other providers in here you might want to use as well. For example, maybe you want to plug in a GitHub provider to provision some repos or something. You can also do this here. In the main TF, actually, before we get to the main TF, I want to touch on this backend TF. So, like I said before, all these TF files are all treated as one big file by Terraform at plan and apply time. I've only got them broken out by a convention, and it just makes it easy to reference things and understand where things are. So this backend TF, earlier on we had a state file over here. When you set up a Terraform backend and you give it a bunch of these arguments, you're telling Terraform to store that state file in S3 on your behalf. We're also using a Dynamo table to lock that state file from being used by anyone else, should anyone else be trying to make Terraform changes whilst I'm making my changes. We absolutely don't want to have two people writing to the state file at one time because that can cause big conflicts. So we've got a locking, a file lock that sits in this Dynamo table that says when I've got this lock, you can't apply any infrastructure against it. This won't matter if it's just you operating stuff on your own account, but it will for sure matter once you've got more than one person. So there are a bunch of implementations for this you can find on the internet, so I'm not really going to cover this in any more depth than what you can see here. So we'll move on to the main TF. So in this main TF, you can see it's basically the same as the other implementation we saw from Anton's examples file. The difference is in here that I've broken out a bunch of my things into something called local workspace with the argument of the name in here. And we'll delve into that a bit more in a minute. But if we go back to this Terraform here and go back to the main page from the registry, we can see this provision instructions, and we've got module VPC source, version of the code, and then we've got the required variables. So that's the starting point for creating a module if you want to build it up from the ground. So we've got a module. I've just called mine Thomas VPC because the name of this is basically arbitrary. It's the Terraform name, not the AWS name. We've got the source and we've got the version. Mine isn't the most recent, I think, from what I just saw on there, was it? This is 370 and I'm on 266. So I've had this for quite some time already now. And then it's the same name, CIDR, AZs, public subnets, private subnets, database subnets. I've got this 3-tier architecture set up. There are other arguments you can add in to add in elastic hash, Redis, intra, all these other things if you want to. I chose not to do that. And then we've got a bunch of these other arguments. You could add specific things like enable NAT gateway, reuse NAT IPs, have a single NAT gateway versus having a multi-AZ NAT gateway, one NAT gateway per AZ. All these settings are overridable, and we can set up some endpoints. So the SSM endpoint, for example. And then down the bottom here, I've also got this code that will concatenate a default set of access control lists with the override for that subnet. So the public subnet with some default subnet rules that I wanted to have set up. And then down the bottom, I've got some tags. So what does this local.workspace magic end up doing? What it is we have a locals TF here where if we scroll down the bottom, what we've got is our workspace equals local.env terraform.workspace. So before we run any Terraform on a production system or even a non-production system for a company that you work for, you want to choose a Terraform workspace and not just use the default workspace for Terraform. And the way we might do that is we would set that as an environment variable the same way we set our profile. This would be Terraform underscore workspace equals, and then it might be something like prod. And you would just press enter on that and that would be done. And then you would export. Oops. Wait, sorry about that. This is export Terraform underscore workspace equals prod. That's the way you do it. And then the next thing I would do after that is I would also do my AWS profile equals Thomas. And then that's sweet. And we can check that that's working by doing AWS STS get caller identity. And that should return our credentials. Right. So this Terraform workspace environment variable will be important so that when we go to choose our workspace here, it will do a lookup on this list right here. So what we've got is local env prod. And when we have our workspace is prod, it's local.env, and then the Terraform workspace is what we set in the shell. So this will resolve to prod. So the workspace will be set to everything that's inside of this prod code block. And these are all of our overrides. And this is an exact one-to-one match of the other thing. So the profile is still, I use a Hamer profile on my account normally. And then I've got everything else set up, the names, the CIDR blocks, the AZs, everything's all here. All the Boolean values are all set up. And then I've got all of my local access control lists, the defaults, and then I've got some publics, privates, the intros that I didn't set up, and then the database rules here as well. So that's all set. At this point, you might be saying, why would I want to do this? The reason why you would want to do this is because if I wanted to at this point, what I could do is my cursor right here, and then come all the way to the bottom to where that closing one is, and then pick all of this up. And I could Control C, Command C, put in a comma, and then paste it again, come back up to this one, and I could rename this to non-prod. And then I could override this with, say, for example, an 11. And then change all of these to 11 as well, all the way through, set all this up, and then have some different configurations in here. And then all I've got to do to redeploy all of this is go into here and then change this export from prod to non-prod, and then do my Terraform plan. This won't work because I'm using different profiles on this machine. And this would set up a whole non-prod account for me. Sorry, not a non-prod account, a non-prod VPC next to my production VPC. And it's as easy as that. We can literally just duplicate entire accounts and have them managed, VPCs. And this could also be an instance. This could be some kind of Elasticache cluster, anything you name it. And we could break it out into non-prod and prod and have all of this managed very, very nicely here. So very quickly you can see how the value of these modules can really magnify themselves. It's very, very nice, and this has been very well implemented. I'm not going to deploy this as it is because, like I say, I don't have the credentials I normally use set up for this. And the other thing is I don't actually use my machine here to deploy this. I have a GitHub action pipeline set up for this, which is a whole different video, which we'll be covering at some other point. So I hope that's been helpful. And that wraps it up. If you've created any resources, make sure you spend some time to go back and destroy them. Otherwise, you'll be giving AWS money for nothing. And I hope you've learned something. The very last part of this this video, I just want to quickly go over the console here and show you the things that have been created by that module that we just stepped through. We go into the VPC section of the VPC console. We can see that the Thomas VPC has been set up. See the VPC ID, and it's available with the 10.10.00.16. It's got a DHCP option set. We've got our route tables and access control lists here. So if we go into subnets, in here we can see that there are publics, privates, and database tiers, and they're set up correctly with 0, 1, 2, 4, 5, 6, 8, 9, and 10. That's all correct. And we can see each of the availability zone IDs, which is the true data center name versus the localized data center name that we're using for the availability zone. And then we've got our route tables and NACLs that are all set up, and some of these are a little bit different. So what we're going to do is jump across to the route table. What's interesting here is that it looks like we've got some kind of mistake going on. What we've got is the main route table is this one here, which is not being used. You can see it's not associated with anything. And that's the one that comes by default with the VPC that we're not going to use. So we're not just overriding this one, we're actually not using it at all. And the module goes out and creates us not just the route tables we need for the database tier and the public tier, but it's also created us 3 private tier subnets. The reason why there's 3 private tier subnets is because of our ongoing NAT gateway issue. Even though that we're only using one NAT gateway, each of these route tables will all point to a specific NAT gateway should I have deployed one, but I didn't deploy one because the current configuration of this would not cost me any money to run. And then the last part down here we've got is the NACLs, where we've got a default NACL, which we're not using. And then we just have our 3 access control lists: public, private, and secure. And that's just about it. The one last point that I want to go over before we wrap all of this up today is that I want everyone to be able to understand really clearly and really concretely what each of these different things that we've just provisioned actually do. So VPC is the container for all of our compute to run in, and the subnets are the broken out areas that we've got within that VPC that we can have different areas of availability should there be a failure domain that we can manage. So VPC and subnet is kind of straightforward. The route tables and network access control lists are the bit that I think a lot of people kind of struggle with and don't really have a good understanding of how to make sense of them. The route table is conceptually the street sign at the end of the street that points down the street adjacent and says, down that road is all the local compute, and down this other road is the wider internet. It's the sign that says this is how you get to that final destination that you want to get to. It doesn't say anything about the allowance of if you can or cannot do it. It just says this is how you get there. So when traffic's being routed through the VPC, the route table is the thing that tells the packets which direction or which interface to travel through to get to its destination. So if you need to get to the wider internet, the default route 0000/0, whatever that points to is where your default route for internet traffic will send your packets to. And that could be a NAT gateway, or it might even just be directly to the internet gateway directly without going through any of those kinds of other what do you call it, appliances, I guess. So routing is that part about the how you get to where you want to get to. Network access control lists is more like a security guard that sits at the edge of your subnet. So a NACL is something like a fence around your subnet, and there's a security guard there with a clipboard that says who can come in and who can go out. Now, there's a distinct difference between the way that a network access control list works versus how a security group works. So a network access control list is it's stateless.
I believe that's right.
Yeah, that's correct. So a network access control list is stateless. It doesn't keep tabs on who came in, therefore who can go back out again. It has an explicit list for who came in, and then it has a whole separate list of allowances for who can go out, and they're in no way related to each other. So if you make an allowance on a network access control list to allow port 80 in, but don't allow traffic back out, that traffic will never be able to return back out of your subnet. So because of the nature of that, you need to make sure you've got allowances in both directions for your access control lists. The difference is with a security group is basically the same thing. It's a fence around your network interface that's attached to your instance. It isn't necessarily a fence around the instance itself, as you can have multiple interfaces attached to one machine, and each interface will get its own security group or groups. You can attach more than one. Now, the security groups are stateful in that when you send traffic in, if there's an allowance in on port 80, whatever the instance has got to do, it will automatically let stuff back out again. You don't need to set an explicit allowance in the other direction. Likewise, if you have traffic that's allowed to go out to the internet to pull something down, like an update, that update will be allowed back in by the security group automatically because it remembered that something went out first. So all of these things in concert with each other is the way in which we ensure that the security of the VPC is maintained. The route table is the sign at the end of the street that says where to go. The access control list is the security guard, stands at the fence around the subnet, and the security group is the security guard that stands at the fence around the network interface attached to either a Lambda, an ECS cluster, EKS cluster, or any of those types of things.